Next concept, pattern programs. That is by using nested loops. By using nested loops. Nested loop is nothing but writing one loop within another loop. Writing one loop within another loop. See, for I is 1, I less than some n less than or equal to n, I plus plus. So then we are writing within this one more for loop. J, let me consider J is 1 or 0 something based on our requirement, less than m, J plus plus. So here we are going to be write the body of the loop. Body of the loop. Body of the inner loop. So this part will call as inner loop. Outside one will be called as outer loop. Now in this, first it is going to be initialize the value. After initializing the value to a variable, then it is going to be check for the condition. If this condition is true, once again, if the condition is true here, it will enter into the inner for loop. So there we are getting the value assigned, that is initialization of value to a variable. Then we are checking with the condition. If the condition is true, if the condition is true, it is going to be execute the body of the loop. Then again, it is going to be increment the value. It is going to be checked with this condition. It is going to be execute the body of the loop. Again, it will increment the uh, j value, will check the condition. This process will be repeated until the condition is false. Until the condition is false. Once the condition is false with the inner for loop, it will comes to the outer for loop. The variable value will be updated here, and it is going to be checked with the condition. If this condition is true, one more time, the inner loop is going to be executed. One more time, the inner loop is going to be executed. So this process is going to be continued until the outer for loop will be outer for loop condition is false. We'll see. Variables I'll be taking I equal to 1, I less than or equal to 5, I plus plus. For j equal to 1, j less than 5, j plus plus. Here I would like to print the I value. If I am printing the I value, what will happen? We'll see. So it is giving one value 4 times, one value 4 times, See here, one value four times. But each and every time it is going to be display the result in the new line. So I'm going to be avoid that. If I avoid that, it is going to be display all the values in single line. So I want to get, see first initially I value is 1. 1 less than or equal to 5, the condition is true. Once the condition is true, it will enter into the inner for loop. There the j value is 1. If the j value is 1, 1 less than 5, the condition is true, it is going to be print the I value. So it is printing the I value as 1. So the inner loop 1, 2, 3, 4 till 4 it is going to be execute. 4 times it is going to be execute. All the time we have given this as to print the I value. 4 times it is going to be print the I value. See, after finishing one row, I would like to make it to enter into the new line. So for making it to enter into the new line, I have given this as system.out.println. Just I didn't write anything. By default, it makes the control to enter into the new line. So now we are seeing the output like this: 1, 1, 1, 1, 2, 2, 2, 3, 3, like 5, 5, 5. Okay. So after this, I would like to use some space. I would like to use some space. We are getting like this. See, now here I am going to do the small change. Instead of I am giving J. So it is going to be vary from 1 to 4. 1, 2, 3, 4, 1, 2, 3, 4. Like 5 lines, it is going to be print. So we'll be having a different pattern over here. We'll be having a different pattern. 1, 2, 3, 4, 1, 2, 3, 4. Just a small modification if we do also, we'll be getting the result in different way. Now we'll see. I'm going to be initialize the J value as 5. I'll be taking J greater than 0. I'll be taking J greater than 0 is a condition. Decrement I'll be giving here. See, first what we are going to get like this. Reverse we are going to get. Reverse we are going to get. 5432. See, if I want to get like this, I value is 1, I value is 1, sorry, j value is 1, j less than or equal to I have taken here. See now output what we are going to be get. I value is 5, 5 greater than or equal to 1. It will come here. I value is 1, greater than, less than or equal to 5. A less than or equal to I. See, we are getting this pattern. So first I value is 1, 1 less than or equal to 5, the condition is true. It will enter here. J value is 1, 1 less than or equal to I value is 1 we have. 1 less than or equal to 1, 1 time I value is going to be print. So then J value will be incremented. 2 it will becomes. 2 less than or equal to 1, the condition is false. So once the condition is false, it will comes to this SOP statement. It makes the control to enter into the new line and it will comes here. I value will be incremented here. I value will be incremented. It will becomes as 2. 2 less than or equal to 5. The condition is 2. So here J value is 1. 1 less than or equal to 5. The condition is true. Once the condition is true, it will enter here. It is going to be print I value. So again J value will be incremented. 2 it will becomes 2 less than or equal to 2. The condition is true one more time. It is going to be execute this loop. Once J value becomes 3, 3 less than or equal to 2, the condition is false. Because of that, it is going to be come this particular SOP statement. It will enter into new line and it is going to be move to the next step. Do you understand this logic?
Yes, sir. If I'm giving like this, I value to print, we are getting like this. If I'm printing J value, if I'm printing J value, here 1 plus 1, here 1, 2, here 1, 2, 3, next here 1, 2, 3, 4, like this. And next 1, 2, 3, 4, 5. It is going to be print. If I'm giving the J value here. Say like this. 1, 2, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, like this. So we'll see. Instead of I, J or something, I'll be giving star over here. I'll be giving star like this. All stars here. Like this, we are getting output. We'll, we'll see another pattern. See, we have initialized J value as 5. We have initialized the J value as 5. J greater than or equal to I. I value initially 1 we have. So I value 5 greater than or equal to 1. So it is going to be print 5 times. Stars 5 times is going to be print. Once the condition is fails, J value will be decremented. It will become as 4. 4 times it is going to be print the star. Like this, it will work. Small changes only I'm performing with each and every logic. But in the result, if you see, we are getting a huge difference. The result or the output we are getting differently. Thinking is most important if you want, for writing these logics. Instead of this, if I'm giving A, see if I'm giving 65 over here, 65, and if I'm giving 70, 70, value is 70, care of um, So I have taken here CH is 65, and here as usual we have taken, we are converting the character into that is CH, where we have initialized with 65, that is giving to CH, and we'll give some space out there. CH increment. See, A. So first it is going to be get 65 here. Always 65. 65 is converted into integer. ASCII value of 65 is, sorry, ASCII value of capital A is 65, capital B 66. So 5 times we are repeating the loop. 5 times we are repeating the loop. If I'm, wait, we'll change the logic. Any doubt you have in this logic?
No, sir.
65, 65, we have initialized this value because we know uh, the ASCII value of capital A is 65. If I'm converting that integer value to, um, if we want to convert that integer value to ASCII value, that is character A, for 65 will be getting A. If I'm giving 1, what will happen for 1? We'll see. Some character we have. ASCII value of 1 will be something we have here. So because of that, 65 is capital A. 97 is for small a. 65 capital A, 66 capital B, 67 capital C, like that. The same way for small a, 97, small b, 98, 99, like that. You see here, small letters we got, small letters we got. Yeah, this integer is going to be converted to correct. Okay. Now instead of this, uh, we are changing usually like I value is 1, here 5, a value has to increment. Mhm. So this is normally how many times the loop is going to be executed. That many number of times it is going to be executed. So here I less than or equal to I, a less than or equal to j. See here. First A, next A, B, C, 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 D, 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 like this. Where is this previously which pattern we have seen? So 5 times A, 4 times B, like this. If you observe here, A, B, B, C, 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 reverse. So instead of this CH, I'll be taking I value as I value instead as 65. J value is 5, 5 less than or equal to 1, the condition is false. See here, A, B, B, C, 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 D, 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 we are getting right. So I want to get A, B, A, A, B. If you are getting like this, see, always it is incrementing. A, B, C, D, E, F, like this. Always is incrementing. Did you understand or any doubt have in this process? So these are some pattern programs how we can able to write the pattern programs. Now we will see the next concept. We will see the next concept, arrays. Arrays. What is meant by arrays? See, arrays is used for storing homogeneous type of elements, homogeneous type of elements in contiguous memory locations. Homogeneous type of data in a sense, similar type of data. If I am declaring the array with the integer data type, in whole array we are going to use the integer. If I am declaring array with a char, I have to store all characters only in it. See, use it to store homogeneous type of data in contiguous memory locations. Homogeneous type of data analysis, similar type of similar type of homogeneous type of data is nothing but similar type of data. Contiguous memory locations in a sense. Let's suppose we have stored one element in the 4000 location. If the integer is having the 4 bytes, next element is going to be stored in 4004. Next element will be stored in the 4008, 4012. Like this, in contiguous memory locations, the elements are going to be stored. So, types of arrays, one dimensional array, one dimensional array, dimensional array, and multi-dimensional array. So, even two-dimensional array we can say as multi-dimensional array. So here one dimension, more than one dimension we can say as multi-dimensional array. More than one dimension we can say as multi-dimensional array, but we are going to be discuss one-dimensional array, two-dimensional array, multi-dimensional array. See, first we will discuss about one-dimensional array. What is one-dimensional array? So here used to store elements either in row or in used to store elements either in row or in column. See, one main drawback we have array is drawback, drawbacks or disadvantages. Drawbacks or disadvantages. Array size will be allocated during compilation. Dynamically, the size of the array cannot be increased. Increased. See, suppose the array size I have given as 5, which is used for storing 5 elements in it. Array is used to store only 5 elements. More than 5 elements, if you are trying to store, it will not allow us. Before compilation itself, we have to allocate a size. How much size is required for us? That size we have to think properly and that we have to provide. If we are not providing like that, it is going to be, if suppose I have taken the array size as 5, which will store only 5 elements in it. More than that, if we want to store, it will not allow. It will give array index out of range. Array index out of range. See, if suppose I have given the array size as 50, if suppose I have given array size as 50, in that I have stored only 20 elements, the remaining 30 elements space will be phased only. Remaining 30 elements space will be phased. We cannot able to use it for another purpose. Memory will be one-dimensional array, which is used to store elements either in row or in column, but not both. See, applications, what we can say, data structure we have, data structure which is used to store the data, which is used to organize the data in some particular format. Data structure is used to organize the data in a specific format. So in that data structure, stack is one application, queue is one application. So to implement this stack and queue applications, we are using this one-dimensional array. For implementing the stack queues, we are using this one-dimensional array. Syntax for declaring one-dimensional array. Data type, array name, size. Data type, array name, size. Example, int a of 5. Int a of 5. Now, int a of 5, this is the array. This is the array. So let's suppose this is the array. See, we have the array A. We have the array A. This is see the indexing of the array will be will starts from 0, 1, 2, 3, and so on. Size minus 1. Size minus 1. See here, A of 0, A of 0, A of 1, A of 1. So array size we have taken as 5. Array size we have taken as 5. 0 to 4 we are going to get the elements. See now here You have two location. You have two location. You have three location. You have four location. Sorry. The syntax for declaring the array is not this. New data, sorry, data type, array name, new data type, size we have to represent here. This is the way we have to declare the array. Int of size 5. Sorry. Data type, array name, new data type, size. With this size, it is going to be allocate the size for array. So now here if you see, we are going to be store some element in this. See, I'll be storing some element here. That is 10. Here I would like to store 20, 30, 40, 50. See, if we are taking the base address of this, the base address of this is 4000. Next, it will be 4004. 4004. It will be 4008. So like this, it will store in contiguous memory locations. This is used for storing contiguous memory location. That is the purpose of using array. So we are initializing the value. Because of that, you have 0 position, the value 10 has been stored. You have 1 position, the value 50 has been stored. You have 2 position, 30 is stored like this. We are going to be initialized statically. Static initialization, dynamic initialization, both the things are there. That we will continue the next session. Now we have discussed here how we can able to declare one-dimensional array, how the example for declaring one-dimensional array, how we are going to be give the indexing that we have discussed, how we can able to initialize the values statically, dynamically, we'll see in the next class.